Okay, so welcome to a new video lesson. The topic of this lesson is identifying proportional relationships from graphs. Now, the previous lessons that we have learned is identifying proportionality from tables or table of values. And the type of problem that we went over are shown below. We were given a table of values and we had to determine whether the two quantities x and y were proportional or not. Now, to answer this, what we did is we checked to see if the ratios y over x were the same. And we know that y over x is the constant of proportionality. So we would look at each values of x and y. Here x is 1, y is 7, so y over x would be 7 over 1, which is 7. And then for the second column, the y over x would be 8 over 2, which is equal to 4. And since the ratio of y over x are not the same, because 7 does not equal to 4, this relationship is not proportional. And again, that's because the ratios of x and y, the ratio of y over x are not the same, or you can also say that the constant of proportionality are not the same. So this was the type of problem that we were doing previously. Now we're going to be looking at proportionality from graph. One thing you need to keep in mind is that for this lesson, you must already know or you must be familiar with graphing points on coordinate planes. If you struggle with that, make sure you understand how to graph points because that's what you'll be doing a lot for this lesson. Okay, so let's start by filling in some blanks in your notes. Make sure you have handouts in front of you. So the first vocabulary that we're going to review is proportional. We've already talked about the definition of proportional. It means when you have the same constant of proportionality. Now there's a different, it's the same, but a definition that looks a little different for graphs. And it says, proportional is a relationship between two quantities, and in our case, we were mostly going to be looking at the quantities x and y. Okay, so relationship between two quantities that vary directly each other. So what does it mean by varying directly? Here's an example. When x and y, the quantities vary directly, it means that as the x value increases, the y value also increases. So one change leads to another change. That's what they mean by varying directly. They're directly related to each other. Okay, so let's look at the three conditions that must be met in order for a graph to be proportional. Number one, the graph must go through the origin. So what is the origin? If you remember from the coordinate plane, your coordinate plane has 4 coordinates. And at the very center, that point right there is called the origin. That's when the x value is equal to 0 and the y value must also equal to 0. So in order for a graph to be proportional, it must go through the origin. And secondly, the graph must be a straight line. And third, all ratios must have the same constant of proportionality or the same unit rate. And I would say that the third one is not as important because if the first two criteria are met, if the graph goes through the origin and it's a straight line, then it will meet the third criteria as well. So I will look at the first two the most. Here is an example for identifying proportionality from graph. So don't copy this down, it's not in your notes, but just take a look at this and read the questions. It says, based on that, meaning based on the 3 criteria that you learned right here, based on this, which of these graphs below would be considered proportional and why? So you have 3 graphs to choose from. Which one of these graphs would be proportional? Okay, try to choose one graph of an answer on your own. And the answer would be the second graph. Now, why is this proportional? Well, first, does it go through the origin? Yes. Is it a straight line? Yes. So that must be proportional. Look at the first graph. Does it go through the origin? Yes. Is it a straight line? No. So it's not proportional. The third one, does it go through the origin? No. So it's already not proportional. So here's the final, very clear, conclusive statement for proportionality from graph. And this is what I want you guys to copy down. Okay? I'm going to write, you must write this. It says, the graph of a proportional relationship is a straight line that passes through the origin. If this is true, then your graph is proportional. Good. So let's move on to example problems now. First example, it says, tell whether x and y quantities are proportional, and if so, find the constant of proportionality. Okay, so right now you're given a table of values and a graph. If this is from the previous lesson, we'll be looking at the table, calculating the y over x to see if the ratio of y over x are the same for each row of values, right? Now, instead of doing that, this time we're just going to be graphing the values. So here, our first values of x and y are 3 and 2. And if you write that as a coordinate, that's 3, 2. So you're going to have to start by graphing all these points onto this graph. 3, 2, x3, y2 would be here. 6, 4, look at the 6 on the x-axis, and you're going to go up 4. Then 9, 6, x is 9, and then you go up 6. And then the last point is 12, 8. Now after you plotted all the points, you should connect these points. Make sure you use a ruler connecting the dots. And here is the graph that you would have. Now, I know that the graph based on using the ruler, it looks like it's going through the origin. But here is another way to check to make sure that it actually does go through the origin. If you take a look at your table of values, if you figure out the pattern, you will see that the y value is constantly increasing by 2 by adding 2, and your x is going up by 3. So if you actually go backwards, you would be subtracting 2, and 2 minus 2 would give you 0. And again, if you're now going backwards, you should subtract 3. So 3 minus 3 will give you 0. So then your x could be 0 when y is equal to 0. So you would have a coordinate of 0, 0, which means that this will go through the origin, right? So is this relationship proportional? The answer is yes. Why? Because the graph is a straight line and it also goes through the origin. So I would say that this is proportional because the graph is a straight line and it passes through the origin. Now let's calculate a constant of proportionality for this relationship because it's proportional. Your y over x is what you need to calculate. You need to calculate the k, which is y over x. If I start with the first values of x and y, it would be y over x, which is 2 over 3. And then the next one would be 4 over 6, which is actually simplifies to 2/3. The next one, y over x, would be 6 over 9. If you divide them both by 3, that's also 2/3. And lastly, 8 over 12, if you divide them both by 4, that's also equal to 2/3. So your y over x is 2/3 for all of these values. Therefore, your unit rate is equal to 2/3. Let's move on to the next example. Again, tell whether the graph here represents a proportional relationship. If so, find the constant of proportionality. So looking at this graph, this is a graph on walking speed. You have x value, which is the hours, y value, which probably the distance that you traveled in miles. So is this graph proportional? Okay, let's first check. Is this line straight? Yes. And does a line go through the origin? Yes. So is this proportional? Yes. Again, because the line is straight and it passes through the origin. So this graph is a proportional relationship. Now, how do we find the constant of proportionality for this particular graph? Because in order for us to find the constant of proportionality, we need to have the y over x. And right now, we don't really have a table of values to tell us what the x and y values are. What you can do is actually create a table of values of x and y. I'm going to do that right here. And look at each point on the graph. This one is 2, 1, meaning when the x value is 2, your y value is equal to 1. Then the next one is 4, 2. When your x value is 4, your y value is 2. The next one, this is 6, 3. And then this one is 8, 4. And remember, your coordinates are always x, y. So if you put all that together, then you can actually calculate the y over x. Your y over x, for the first values, you would have 1 over 2. And the second one will be 2 over 4, which simplifies to 1/2. And the next one will be 3 over 6, which also simplifies to 1/2. And if you want to do the last one, it's xy, so y is 4, x is 8, which also simplifies to 1/2. And you can see that your constant of proportionality are the same, which is 1/2. That's it. Okay, so I would like you to try these practice problems. Please pause the video, try the problems on your own. When you're done, you can come back and check your answers. Okay, so let's come back and let's review this problem together. It says, tell whether the graph here represents a proportional relationship. And if it is proportional, find the constant of proportionality. Well, looking at the graph, it looks like a straight line and it's going through the origin. So this would be yes, it is proportional. And the reason is that the line is straight and it passes through the origin 0, 0. That will be our reasoning. Now, since this is proportional, now we need to calculate the constant of proportionality, which is k equals y over x, right? So we need to identify the y and x values of each point again. So this point here, it's going to be 2, 3. This point here is 4, 6. So if we create the table of values, our first x is 2, when y is 3, and then you have x value of 4 in the next point, and the y value is 6. So your y over x for the first one is 3 over 2, and the second one is 6 over 4, which also, if you divide them both by 2, simplifies to 3/2. So they both have the same constant of proportionality, which is 3 over 2. Okay, let's move on to the second practice problem. Again, please try this problem on your own, and then you can come back to video to check your answers. Okay, so let's determine whether this following represents a proportional relationship. And again, if it's proportional, you need to find the constant of proportionality. Okay, again, since we have a graph here, instead of calculating the y over x, we're going to just go directly graph this. So if x is equal to 3, y is equal to 1. When x is 4, y is 2. When x is 5, y is 3. When x is 6, y is 4. So these are the points that I get from this table of values. And now I'm going to connect these dots using a ruler. So this is what my graph will look like. So looking at this graph, is this proportional? Is this graph proportional? No, it's not proportional. Why? Because the graph is straight, but it does not go through the origin. So again, it's not proportional because the graph does not pass through the origin. And if this is not proportional, okay, does it have a constant of proportionality? Nope, there is no constant of proportionality because this relationship is not proportional. Okay, so that's the end of this video lesson. You will have to do a few worksheets. There's a classwork that you're going to have to complete, and there will be a homework number 2 for this assignment for today. So please make sure you complete them. If you have any further questions, make sure you write it down or make a mark on it so you can ask me next time. Okay? Thank you.